section 7 is all about inverse relations and functions. We'll talk about the inverse of a relation or function in that matter, and also be able to determine if it's a function as well. So an inverse relation says that if you have a regular relation like A, B, its inverse would flip it. So for an inverse, you flip the order of the x's and y's. The x's become y's, and the y's become x's. If you start with a function, and its inverse is also a function, then we call them inverse functions. So if you take a look at example 1, what is the inverse of relation W? So relation W is on the left, so that means that 2 maps to 0, -1 maps to 4, -3 maps to 2, and 5 maps to -1. First thing we want to talk about is that relation W a function? So look at all of the x values. If an x value repeats, it has to go to the same y value. None of those x values repeat. These x values right there, none of them repeat, so you don't have to worry about it. This one is a function. To find the inverse, just switch the x and y values. So the x column, the 2, -1, -3, -5, goes to the y column, and vice versa. The y column in the original goes to the x. So now I want to determine if that inverse is a function. Look at the x values. None of them are allowed to repeat, and none of them do, which makes it a function as well. These would be considered inverse functions. Example 2, they want the inverse of relation M and determine whether everything's a function. So look at relation M first. Those values, none of them repeat, so this is a function. To find the inverse, just flip the columns. Those x values go to the y column, and the y values go to the x column. Take a look at the inverse. You'll notice there are 2 5s. There's a 5 there, and there's a 5 there. Because this 2 doesn't match that -2, this is not a function. So they would be inverse relations, but not inverse functions, because the inverse doesn't count. To find the equation of an inverse, there are 2 steps. Step number 1 is to switch the x and y. So the x variable will become a y, and the y variable will become an x, and then solve the new equation for y. So number 3, they want me to find the inverse of y equals 2x plus 8. So the first thing I'm going to do is switch it and make it x equals 2y plus 8. That's step 1. Step 2 is to solve that for y. To solve this for y, I'll start by subtracting 8. Gives me x minus 8 equals 2y. And then I'll divide both sides by 2. And you should really pretty that up. Also switch sides. X over 2, your uncommon denominator, gives me a 1/2 x. And then 8 over 2 gives me a -4. It says, is the inverse a function? Y equals 1/2 x minus 4 is a diagonal line. Generally speaking, it would kind of look like that. And so this is a function. It'll become a lot more clear when I show you an example of one that is not. Number 4, find the inverse of y equals x squared minus 1. So first step, switch the x and the y. I'm going to make that x equals y squared minus 1. First step in solving that for y is to add 1 to both sides. So I have x plus 1 equals y squared. To undo a y squared, you have to square root. Last chapter, or actually the beginning of this chapter, we learned that if we square root when it's our idea, we do need a plus or minus. So you need a plus or minus on the left-hand side. What we really have, and I'll switch sides for you, is y equals plus or minus the square root of x plus 1. I know you're not quite sure what that looks like yet, but this graph, that y equals plus or minus the square root of x plus 1, kind of looks like that, which makes sense because the original problem, x squared minus 1, was a parabola, and so its inverse kind of flips onto its side. This is not a function, because if you drew a vertical line anywhere, the vertical line test, it would fail miserably throughout the entire thing. So anytime you have a parabola, its inverse is not a function. So the answers you're looking for here are right there. All right, find the inverse of y equals the quantity x plus 2 squared. So the first thing I'm going to do is switch letters. To undo that quantity squared, I'm going to square root both sides. This one needs a plus or minus. That one doesn't because the square and the square root cancel. So what I really have is plus or minus the square root of x equals y plus 2. And then I'm going to subtract 2. It is really important that you see that the plus or minus square root of x is separate from the minus 2. That radical doesn't go over the negative 2. It's two different things. This also will not be a function because its inverse is plus or minus. Plus or minus means for every x value you put in, you'll have two y values. X would repeat, and that makes it not a function. It would fail the vertical line test. Number 6, first thing I'm going to do is switch letters. X equals 1 minus y squared plus 3. To solve for y, I'm going to start by subtracting 3 from both sides. Gives me x minus 3 equals 1 minus y squared. To undo that squared, I'm going to square root the left and the right. The left-hand side needs a plus or minus. In the next step, I'm actually going to switch sides because that tends to be uncomfortable when what you're isolating is on the other side. I'm going to undo the 1 out front by subtracting. Now be careful with what's going on here. When you subtract 1, you get negative y equals plus or minus the square root of x minus 3 minus 1. But you have a negative y, so you have to essentially divide everything by a negative 1. Now, when I divide a plus or a minus by a negative 1, I would still get a plus or minus. So that's not going to change. But the minus 1 on the end becomes a plus 1. Also will not be a function because of the plus or minus.